The concepts that AB is going to go through may seem familiar to you, tiering, replication, continuous data protection, but believe me, they're very different in this cloud world, and AB is going to take us through that and articulate that. So AB, why don't you kind of take it away, and we'll talk first about sort of innovation in tiering architecture.
Yeah. These are like three. I'll touch upon three important critical capabilities, and the first one is the lifecycle management. There are like in terms of the features, MinIO is a complete object storage, like all the way from predicate push down to Lambda computing. All of that is there, but these three we picked specifically because of the nature of the enterprise readiness for the object storage. These three capabilities existed in all these file and block world for a long time, right? But for object storage to take on critical enterprise storage market, these are important functionalities. While the functionality requirements are pretty well understood, the scale is very different this time, and even the behavior is different. Right? Like doing all of these at a small scale is pretty easy, but doing it at a larger scale, like a lot of times customers start with petabytes of data, and to do these at large amounts of data and fast is actually no easy task, right? And this is where, like, starting from the ILM capabilities, our core philosophy is always try to be S3 compatible, right? And Amazon introduced these tiering APIs as part of the lifecycle management API, and we started with the same foundation, exactly Amazon compatible. And then you also have these ILM capabilities you can apply it at a bucket level, even at an object level. I only want these objects with certain tags under this particular prefix or a folder. Only those objects I want this policy to be applied. You can go pretty granular, even at a single object. I only want this object to this policy to be applied. You could do that. And now, once the foundation is clear, then we actually pushed it to the next level, because unlike Amazon, our requirements are even broader, because we have to run across public cloud, within public cloud, and even within private cloud. We have different storage tiers. So next slide, Jonathan.
Yes.
Right, like on the common type of tiering that we use in the private cloud world is the hard drive to SSD. This actually started growing in the last 2 years, last 1 year, I would say. What we always saw that the performance market and the capacity market, they were actually quite separate market. The analytics one, they were all hard drives, and then the financial world, the machine learning, AML applications, they were all SSD. But now we are seeing there is a convergence. Almost everybody is now going towards SSD, but then you can't really have 10 petabytes to 100 petabytes type all SSDs, at least today. While it's possible, it is just exorbitant, right? And this is where the convergence is happening, and the tiering of hard drive to SSD to hard drive is now becoming quite common. In the lifecycle management policy, the same API, you could simply create two tiers, one tier, SSD tier and hard drive tier, apply a policy, even say, I want all buckets or only this bucket, or objects matching certain pattern, certain tags. I want these objects, say after 6 months old. It's highly unlikely someone would access these objects, but it's possible. But you tier these objects, freeing up the space for the hot tier to take on the active objects. We almost find that 30 days to 60 days and then 90 days, the usage probability of usage falls off. Most of the hot content is well within 90 days. And after that, it becomes nearline. So it makes sense for those objects to free up the hot tier. But once it is transitioned, the application shouldn't do some stunts like restore API. Well, S3 API is there to restore object back into rehydrate to the hot tier. But from application's point of view, these are completely transparent. When you access an object that has been transitioned, say 3 years old, MinIO will automatically transition it back or stream it back to a transparent tiering between hot and cold. That's all MinIO's job. But the same capability, same policy, you can actually extend not just between SSD and HDD tier. You can actually create a public cloud tier where it's a remote MinIO. It could even, the remote tier could not necessarily has to be MinIO. It could be Amazon S3 infrequently accessed, which is quite cheap, right? Or it could be Azure Blob Cold Store, Google Cold Store. You want my hot tier to be in private cloud, and you want the aging data to go to public cloud for cost reasons. For practical reasons, I cannot afford to have a large data center on-prem. You want to create a truly hybrid cloud tiering. The same capability extends between public and private cloud. The other interesting part we noticed when we started seeing a lot of deployments in the public cloud was the users were adopting MinIO inside AWS is actually a great example. When we saw such high adoption, we were telling them that you are actually running us on EBS block store. Why not use Amazon S3? Right? EBS is 3 times more expensive than S3 itself. Why would you run MinIO on EBS? And their point was that it's for productivity, scale, and the ability to go multi-cloud. They chose MinIO and they want to keep it that way. This is where the tiering between the block storage to the S3 infrequently accessed store. Now you can actually manage your cost at large scale too. You spin up a 4 petabyte cluster on AWS. MinIO will manage the data between EBS and S3 IA, freeing up the EBS aging data. So EBS only acts as a hot tier. Even if you use NVMe, the costs are pretty well under control, and you got true hybrid cloud, multi-cloud capability. So the same ILM foundation becomes very effective whether you are in the cloud, across cloud.
So AB, the tiering is only hot and cold tiers, so they're not like multiple levels, 4 or 5 different levels of tiering here, or is it flexible enough to do something like a 3-level tier, or what?
So the capability inside MinIO exists because we are looking at the policy. Like you could do 2-3 level. We are not talking about it much. Like say, for example, the same functionality, you could actually, can I set up a compression tier? Everything that goes there gets compressed and then gets transition from there, things like that. The code exists, but we are not exposing it simply because this is a powerful capability we like, right? But then the mass market, they are still warming up to this idea. I don't want to give them a loaded gun.
Okay, thanks.
So, AB, is the same for the duplication, for example? I mean, so having the ability to compress the data in several ways, so to save money, if you are installing MinIO on AWS, for example, okay? Mm-hmm. So to become, anyway, more competitive, okay?
Exactly. Yeah.
On the dollar per gigabyte. So I don't understand why not. I mean, there are others that are, tempting this path anyway.
Yeah, no, I'm sorry, I didn't understand the question.
So I don't understand why you are not implementing or you are not thinking about implementing these features if you want to, get a good dollar per gigabyte.
The compression capability.
Yeah.
So actually, compression capability also there is compression I was talking about compression as a tier, but compression itself exists inside MinIO. We don't talk about it. The reason because Amazon only doesn't. Amazon, I don't know whether they're doing compression in the back or not, but they don't. There is no compression API. But we actually implemented compression API. It's one of the fastest compression libraries that uses SIMD instructions like AVX512 type instructions to do streaming inline compression. That functionality exists in MinIO. Some discovered and started using it. The reason I'm also not talking much about it, I'm also finding that most of the time they actually compress and upload the object. These cloud native applications, AIML applications are pretty smart. Because they also want to conserve the network bandwidth, so they would compress and upload. Like where you can see particularly if you bulk of the data is in compressed CSV, JSON, Parquet, ORC, they're all compressed, right? So they would upload a compressed CSV file, but then can I now do a SQL query predicate push down on a compressed CSV file without downloading my compressed file? I have to download, expand, only then I can peek into it. Can I send a SQL query on a compressed CSV file? MinIO can do that. Even that is independent of whether you enable compression or not. We can even peek inside this object and do the predicate push down. So these capabilities actually exist and people are taking advantage of it. Generally, I want I want the mass market to think of simple features, get started, become expert, then you take advantage of advanced capabilities. But yes, it exists, and I'm in complete agreement with you.
Great.
Okay.
Maybe why don't you tackle next generation replication?
Yeah. So this replication part, it is a must-have for every enterprise requirement, right? One of the questions I think Ray asked, like, can I do this? Can I run MinIO across? Like, can it span across multiple cloud? The demo what Daniel was showing was each cloud runs their own MinIO cluster, and they are replicated instead. There are some customers who actually have pretty good infrastructure, particularly in the telco space, and we also saw. I can't name this one. It's actually a very prominent brand in the cloud space. They actually want erasure code across multi-data center, multi-zone. That's all supported, but the specific feature here, I will talk about the replication part. The replication part seems to be the most common one. They actually want public-private cloud or across private cloud or across public cloud. They want 2 sites or more sites in active replication. The hard part is actually the scale, right? Like to be able to do this at peta scale and keeping them in sync, the traditional replication model, you have to snapshot and then you take a snapshot and push it, because as you are pushing the replication to remote site in a file and block is hard because you can't get consistency right. In object storage, you can do that because the replication is built on top of versioning, so we can actually achieve a very large scale. Like if I have a 100 petabyte bucket, can I do active replication on it? Absolutely. Now the active part is the critical requirement in the enterprise space. Amazon, when they introduced their bucket replication API, they said the remote bucket has to be in a different name. They only address the DR scenario, and even the SLA of Amazon's bucket replication is 15 minutes, up to 15 minutes, 99.99% guarantee. I can't be really sure all the objects will always be there, but that's not good enough for the enterprise applications. The common requirement we actually get is active synchronous replication. Even if it is async, it is near synchronous. The objects are immediately pushed to the other side. It's just that you are not blocking until it's committed to both sides, that you don't care about strict consistency across the sites, but it has to be near synchronous. The MinIO's replication, while it looks like S3 compatible, it's the same API, it actually from application point of view, even you are simultaneously reading and writing, some request went here, some request went there, you can achieve full strict consistency across the site. And to be able to do this at long distance, some of the customers actually are running cross-continent, one Europe, one in US, around 130 millisecond latency, and to be able to do active replication in the file and block world is pretty hard. Here, every object, synchronous and asynchronous, long distance, high latency, it is possible because of the nature of S3 API and how MinIO is architected. So the common thing that we always tell the customer, unless you are just talking about DR, just make a copy and then
AV. So it's synchronous across the world. I mean, Europe to US, and it's a synchronous replication, active, and it's consistent across all those worlds, those continents.
So if you look at the S3 per call, right, it's a REST API call, right? These applications.
So it's got a more latency is okay, I guess, right?
Yes. Because the call itself is actually more throughput. If you see if you're a web application or any application, right, you upload a check scanned image of say 4 MB. The 4 MB it's not a 4K multiple operations, because in the block or file world, I can't tell which all blocks belong to the same transaction. I have no context sitting at that layer for replication. I have to wait till the snapshot is complete at the whole LUN level, right? Here, every call is atomic and it's just a REST API call. All I have to tell the application developer is, okay, do you want your REST API call put object to block until it's committed there as well, or you want it to commit strictly consistent synchronously to this side? As soon as it's committed to at least one side, I can let you go. Say I acknowledge, and then I do a background async replication, whichever you want. Most of them, they say, as long as the object appears immediately right there, I don't care about strict consistency across sites. But in some customers' case, I found in the financial space, they're like, no, I want that assurance. I will rather pay the write time latency than read time latency. Even when the object is not there, if you chose async path, if the object has not appeared in the other side and now the read went there, MinIO will do the transparent proxying. So the fun part is it's just a REST API call. If you are accessing a website in Europe, it just works, right? So it's underneath a single web page call, you will see a bunch of HTTP calls fetching multiple images. It's actually it's not at all that hard, given that MinIO has no metadata database. Every operation is just atomic and idempotent. It just works, right? So it's nothing surprising for us, but it's hard for others to get it right because they look at object storage as just a S3 API proxy on a traditional file and block world. For them to do this right, because they also have to handle file and block replication, they handle it at that layer. It's very hard for them. For us, it's a web web API level replication is pretty easy to do. Yeah, this one, it's one of the underappreciated or probably unnoticed feature in the S3 API, and MinIO took full advantage of it, and now customers are noticing this. Because the objects are versioned and every single mutation is automatically a new version of the object, finally, we can make CDP a reality, right? CDP in the file and block world was very hard because the transactions were very chatty, very small, and if you have to track every single transaction to be able to roll back, the POSIX world didn't even have a neat API for file-level versioning. To do this, even at a block level, the closest thing we got is snapshotting, and you can't do continuous snapshotting. To do this in their world is very hard. For us, we also have to do this at scale. The nice part is, once you enable versioning in a bucket, every single mutation is a new version of the object. Now, building on top of that, we are now basically eliminating the snapshots and then going towards object level granularity. Pick one particular object and say, I want to go back in time and then as of 3 days, 2 minutes, 2 nanoseconds before how that object looked like, can I get that object out? Or forget about that single object. This whole subdirectory, I want to travel back in time and look at that namespace, or even the whole site or a whole bucket. Can I go back in time without snapshot and then read that namespace? Here, it's not even like you are rolling back. You can go any point in time and just read it. There is no RPO, RTO. It's like we now finally reduced it to 0. And it is all the time, it's just the default behavior. And now those things are now getting visual in MinIO console and command line. Daniel will show you how to do it. In fact, like everything Daniel is doing, you could do this through command line too. Even the nice fancy things he did with the UI, you can save it as a YAML from the UI itself. First time, once you are familiar, next time you can do it through the kubectl. That is how pretty much all of them, once they get familiar, they do it all through the command line, through the YAML file. And you don't have to come back to UI even.
Yeah.
Daniel, it's all yours.
Sure. So in this part of the demo, we're finally, we've been only talking about infrastructure, setting up object storage and manage it across different cloud providers. And we're finally reaching the point where we're now investigating and managing object storage, right? So this is our management interface. You'll see on the left side that I have way more options to manage my object storage. I'm greeted by the same set of metrics that tell me what's going on with my object storage infrastructure. But then this is, again, all about self-service, right? So we don't need to have your users actually go to the CLI, even though they can every time. They can come here and discover the features that they care about. Let's say they want to manage a bucket. They can come and say, okay, let me create a bucket for a demo, right? And they can even discover and configure the features, right? We were talking about, David was touching about versioning, for example, where if let's say I'm storing multiple machine learning models on the same bucket, and perhaps I want to keep all of the versions so I can quickly roll back. I can enable versioning. Perhaps I want to be protected against ransomware attacks, and I want to actually enable object locking. So no one should be able to delete anything from this bucket, right? So I can actually protect even all the previous versions. But perhaps, that will eventually run you out of space. So perhaps you can even enforce a retention policy and say, I'll be enforcing that retention policy for up to 180 days, right? Something like that. Perhaps you're working in a multi-user system, and instead of doing whole tenants, you actually just want to delegate a whole bucket to a data science team or a business unit, and you're going to give them a hard quota. Let's say they want to put, let's say they're doing backups on this bucket, so you want to make sure it's only 1 terabyte of capacity that it's going to be used in this bucket. or perhaps if it's backups, actually, you want to enforce a FIFO quota, right? So, and then, if the bucket becomes full, all the backup will be pushed out and new backups will still go in, right? So it's all about discovery of the features, right? It's all about self-service. This is the experience that users have come to expect from the public cloud, and now they can get the same one on every single cloud provider plus on-premise. Now, some of the things that we were talking about, right? So, for example, for this one setup, I have here a large number of buckets. And on my other data centers, I set up different set of buckets. I'll be actually going into them. So for example, here I have, plenty of buckets. And on my Azure, I only have the assets that I actually want to keep online, right? So perhaps assets, data sets, machine learning models, video assets that I want to keep online and do replicate across different cloud providers with different latencies. And on my on-premise deployment, I actually kept sensitive data that I want replicated here, maybe my logs, my HR data, etc. And it's very easy for me to come through this interface and configure, let's say, for my asset bucket, and I can see and again see all the capabilities that we offer. I can easily set up replication from here, from this part, right? So just by following some simple steps, I can set up replication. I can set up lifecycle management rules. And this is even one of the parts that we want to show you, right? How this even works. So let's say here I have two instances, right? So I have my Google Cloud instance and my Azure instance. So, all right. So, okay, let's wait for this one to load. So the whole idea of this of showing you this is that I actually set up the replication part. And what happens if I actually upload a file on one of my clouds? And the latency even between cloud providers, between regions might not be great. So I upload the picture here, and it's immediately on the other location, right? This is where we're talking about setting up replication about different clouds, right? Whether it's different cloud providers, different regions, different continents. It's all supported by MinIO, and this is very easy because it allows you to. I touched on the part of setting up different buckets because perhaps you want to keep some data local to some countries, and you want to set up replication guarantees that are only relevant for those buckets within those regions or those countries, and that's very easy and transparent. Another thing that we touched upon was
multiple objects just to show.
Sure, of course.
The latency part is actually it's hardly visible because even this is even cross cloud, right? Like it just quickly captures.
Yeah, so I have a bunch of objects now, and I'm just going to hit refresh here, and all of them are coming very quickly. So the other part that we were discussing was the versioning, right? So here I have a bucket with some cat pictures, and I can actually go and explore, for this one file, all the previous versions that I've actually had in the past, right? This is what's also protecting you, like if you want to go back in time. But Avi was actually talking about the capability of actually not having the need to snapshot your object storage if you can just go back to a point in time. And let's say, for example, I wanted to figure out how did this bucket look like yesterday, right? So I can actually do a rewind and say, how does this look yesterday at 10:47, let's say, right? And I can go back in time and just rewind and see that I actually had a specific version of the file, and I only had one file in this bucket. So even though now there's even more files in this location or this prefix, this folder, I can immediately go and see what I have there. And if I need to recover one of these files, I can. So yeah, lastly, one part that, because we're running out of time, I even across all of these things, I can also set up, we talk about the importance of setting up tiering of data. Actually, something that we may not have much time to go into, but I actually set up different tiers, so I can actually tier my data to different cloud providers. In this case, I set up a tier into AWS, so I can actually tier data after some amount of time to S3 to cut cost. I set up another MinIO tier, right? Because I may have a different MinIO tenant on my same Kubernetes cluster that's using hard disk drives instead of NVMe. And I also set a Google Cloud, and there's nothing stopping me from even setting a fourth tier, right? We support even Azure. And that's a part of our hybrid cloud strategy where we're actually telling you, offload your data from your hot tiers into colder tiers that, make it so you can actually cut costs. And something, the way I actually set it up, I set up 3-tier data buckets, and pretty much the data is just getting tiered into these cloud providers. And setting it up because pretty straightforward, right? So it's just a lifecycle management rule that says, after one day, push the data out of my NVMe drives into this different tier. But yeah.
For Microsoft Azure, you support the blob APIs, right?
Correct.
Yes.
Yeah. When we tier to the blob, when you add basically the blob Azure account, click on that, Daniel. This time it speaks a native Azure blob API to tier the data to the blob volume.
Okay.
Yeah. And if you're taking to Google Cloud, they usually work this service account concept rather than actually static credentials. So we actually let you configure all these tiers, and that's the point that we wanted to show, right? Here you see I'm tiering straight to Amazon or perhaps to Google Cloud, or even inside my Kubernetes cluster, right? Maybe I don't need to go that far. And I just set up different tiers within my own Kubernetes cluster. And I have my rules to say, this bucket, I need the first 30 days or the first 60 days on NVMe. I need that to be fast data. I need to write and read it fast. But after 60 days, perhaps I don't have the need to read it as often. I'll be tiering it to solid state drives, and I keep it there for 6 months. And then I'll be tiering it to hard disk drives. And then after 2 years into a really cold tier on the cloud, right? So it's all transparent. If I actually go into this, any of my tier buckets, all the data is actually already somewhere else. Actually, let me browse into that one. All the data is already somewhere else, but the application doesn't know. The application is pulling these files, and he may not know whether the files are actually sitting on the NVMe drives or they're already sitting on a different tier, right? Because once they want to download one of these files, the file will be streamed out from the tier where it's actually stored.
In fact, we find most of the time, instead of getting machines with some NVMe drives and some hard drives, like in a hybrid same machine, as it is, the NVMe drives don't have enough PCIe lanes. You also need some lanes for the 100 gigabit NIC. So they actually buy dense 4U JBODs, 48 drive, 96 drive chassis, and then they buy 16 drive NVMe chassis. These are actually separate clusters, separate racks, all flash rack and all hard drive rack. And then 2 MinIO clusters, and they tier between these 2 clusters as compared to same physical hardware, say server, co-locating NVMe and hard drives.
What is clear here, hopefully to you, is that the features that we're talking about in the multi-cloud and hybrid cloud world fulfill the promise of basically commoditizing infrastructure as a service. But you have to be able to do all of these things. If you can then go shop for the best price performance trade-off or price performance configuration that you want anywhere on the cloud. Oracle, AWS, Azure, Google, it doesn't matter. It basically commoditizes the cloud in a way that benefits the enterprise immensely and puts them in full control. And whether you're doing it through tiering, which is the key to efficiency and economics, right? Whether you're doing it through active-active replication, right? Which is exactly what enterprises want to protect their data and do so in a way that's both economical and performant. And then finally, continuous data protection, which is basically time machine for object storage. It's remarkable what we've achieved there. These are things that we're doing that nobody else is doing, right? We're way ahead of the industry on this. And that's why we're getting adopted in such big numbers, both in the public cloud, the private cloud, and these Kubernetes distributions. So listen, let's wrap it up. I said there were 3 things in the beginning, and if you only remember 3 things, let it be these 3 things. Here we are, we got 3 things. Hopefully we've proved to you over this presentation that we are positioned to win both the hybrid cloud and the multi-cloud. If you think about the public cloud, it is a simple fraction of a fraction, which is the overall prize, which is the cloud, right? And it's comprised of hybrid cloud, multi-cloud, public cloud, edge, Kubernetes distributions. It's a fraction of the fraction. We're looking at taking the whole thing. That's what we're focused on. And the features that we've shown to you today are the things that we think are going to drive that success over the next 12 to 18 months. We're clearly leading the industry in all of these things. Nobody else has the capacity to come close to what it is that we're doing in the way that we're doing it. And we think that's going to drive even more adoption than the growth that you've seen thus far. And I think the last piece that matters is that, from a frictional standpoint, we understand exactly where it is that we need to basically allow for enterprises to adopt us but at the same time have a commercial path in which to engage them when things turn to production, and that's the AGPL license. And our model really works and has been really working very well for us in driving both new customers, but also continuing to drive great penetration.